Okay, let's see the OpinAIS framework in action. For this demo, we're going to use the US Congressional voting records dataset provided by the Machine Learning repository of University of California, Irvine. Here in this URL, you can see more details about this particular dataset, but now I'm going to show you the dataset file, which is composed by, this is the class of the US Congressman, which can be either Republican or Democrat, and this is the particular vote for each congressman for voting. It can be either no, yes, or those question marks here, which are abstentions. So you can see that each congressman has a particular record of votings, and of course it belongs to a certain political party. This is the file here, and I'll tell you a little bit about the encoding of these individuals. To begin with, I can say that, okay, in the technical report, I describe what are the steps to implement the support for this particular dataset, and it tells about the development of the individual's factory, the readers, the factories, and the item definition. But I'm not going to go into further detail here, and I'll just detail a little bit encoding of these individuals, and then we'll see what are the results. So regarding the encoding, as there are three possible values for each vote in this voting record, no, yes, or an abstention, we are going to use a 2-bit number for representing each of those. For instance, and I'm going to write it here, we could say that this individual will be represented, this no here will be represented as a 1-0, right? Like that was a couple of bits representing the no value. The yes value will be represented with a 0-1. And finally, the abstentions will be represented as 0-0. I'm going to put it other way to make it clearer. This is no, this is yes, and this is an abstention. Right, so we're going to translate these individuals into binary string by using this translation table. You can see that there is no particular value for 1-1, which actually doesn't matter. And also, this encoding is not random at all, because we can see that opposite values, as it is yes and no, has the maximum Hamming distance here, which are in this case the 2 bits. So we want to make yes and no to be represented as differently as possible. So that's all about this representation. And now let's move to see some of the properties for executing the framework over this dataset. In the first place, we have to set the possible types, which in this case, or the possible classes, which in this case are Republican or Democrat. And now we are going to set some of the Java classes which are going to parse this dataset. For instance, the reader, which is the voting records reader, and the voting records individuals factory, which are those classes here, this and this, which are setting up the conversion from the input individuals into a binary string representing each of those. Later, we say we configure the path of the file containing the dataset, which is indeed this file. Maximum number of individuals, 0 means all, so I'm not going to ignore any of those individuals. We can also configure whether those individuals are balanced or not. In this case, we're not worrying about that. the size of the detector's population or the antibodies population, the length of the features vector, I'm writing here 16, which are indeed the number of votings that we can see here. Each individual is categorized for 16 different votings. Preprocessors, okay, in this case I'm not running any preprocessor, as those are more fitted to do some natural language processing, which is not the case here. The percentage of the size of the testing set, the test set, which in this case will be the 30% of the total population of individuals. And now we can also set the algorithm, which is we're going to run. Here we have some metadata regarding the construction of this algorithm, which in this case are taking the main constructor of this algorithm. We're going to say the types and the values. And these values here, those values here are going to be detailed further. Type bias, the generality bias. I'm not going to go into further detail here, but in the technical report all those parameters are described. So we are just choosing some values which give fairly good results. And okay, let's run this. Now we execute this. Okay, we can see here the distribution of individuals for each class. We see that is clearly unbalanced, but we're not worrying a lot about that. It vectorizes individuals, it generates the training and the test sets, and now it's running the evolutionary algorithm. Okay, now it goes pretty fast, so it's okay. And in the end, we can see the best detector for each type, which is just the representation of the antibody. And finally, the confusion matrix and the hit rate. Okay, this is the training set, and this is the test set. And we can see that the results are pretty good here. Well, as we can see in the confusion matrix, there is no many mistakes regarding the classification of individuals, and we are having a hit rate over the training set of 97.5%, and in the case of the test set 89.2%, which are pretty good in both cases. Regarding that, a random guess over the most populated class would be 65%. So this algorithm is clearly providing a huge advantage when classifying this dataset. Okay, just to finish with, I'll say that this dataset is pretty easy to classify, so results are usually very good, and mostly is used only for validation purposes rather than for evaluation. As well, politicians here in this case have very clearly defined thinking or ideological thinking, so this dataset is pretty simple, right? And that's all. I hope you enjoyed this demo and you can get a better idea of how the OpinAIS framework works. For more details, you can read the technical report, which describes, as I said earlier, some information to implement all classes required for parsing new datasets. Thank you very much.